Now I think you can see LAB1 sheet. Today I am going to talk about LAB1 sheet, and I will explain these activities. There are two sections: algorithms, flowchart, and other from this second one. First one is algorithms. Second one is about the C programming, activity 2.1, and like that up to 2.11. This activity 1.1, write an algorithm to input two numbers, multiply these numbers and display output. Okay, now this session 4 is you can see this you can see read about algorithm in session 4 in your book 1. Read the question activity 1.1 of lab 1 quiz. Write the answers. So that is no need. Okay, read the question. Now activity 1 is write an algorithm to input two numbers. Algorithm. Okay, now the question is this. Now first of all you have to write start, then input first number, and input second number, and multiply these numbers. Multiply first number and second number. After that, display the result. You have to you can say like this also, and store result. Multiply and store, and display the result. After that, after finishing the algorithm, you have to write end. This is a quick answer, okay, for the activity 1.1. Usually in algorithm, no need exactly the program. Just you have to write steps in whatever the goal or question. You have to write how to complete this task. You have to actually write what to do. Okay, what steps you have to do to complete a given step, given task. That is algorithm. Okay, if you have any question, please ask. Okay. No, well, this is only if we have not participated lab 1 physically. Some some students are available uh, not participated, still not couldn't participate a physical session. So you have to you can participate for this online session if you have not participated. And no need to upload anywhere this assignment. Okay, activity 1.1, 1.2, write a pseudocode for the first question. That also described in session 4 in book 1. Pseudocode is the first one is algorithm. Pseudocode is more like program. Okay. Now, uh, actually, a pseudocode should be written to. Uh, um, it is more like programming languages, but not exactly because the programmer can choose uh, there are different programming languages, Python, C, uh, and like Java, like, and there are so many programming languages. So the programmer and the team can decide what programming language decide to implement these algorithms. So we can write at the beginning. You have to write the algorithm because um, when system analysis and design, uh, they don't exactly they don't know exactly what the programming uh, system has to do. So actually, in system analysis and design, the complete software divided into smaller modules, so which can uh, manageable to uh, code, manageable to and that can easily code. So these small modules we now usually write uh, algorithms to do this small task, small module, to complete module or small task. So at the beginning, you have to write uh, algorithms. Then after that, you have to write pseudocode uh, the better way. Okay. Now, how to write? Now you have to write begin or start or begin. Okay, begin and uh, give a tab to separate the code block. Prompt prompt is you have to input. Okay, enter first number, read num1. Okay, this variable name. Prompt, enter second number, read num2. This is prompt and this is the variable num1, num2, and then product. Product is equal to the num1 multiply num2. Display the product is product. Okay. And end. Usually these things we can write in capital letters. Okay. Begin, prompt, read, prompt, read. Product is those things are variable, no? So display end. So this you have to customize these things. And prompt is uh, given by the software, and we have to whatever we want customize these things. We can write in simple letters. What is activity 1.3? Draw a flowchart. For the second question, draw a flowchart. Okay. For the to draw a flowchart, I am using draw.io software. Okay. You can use any software. I usually use this software. If you have any problem, please ask. Okay. There is a separate section flowchart. This is here. You can see start. There are some symbols. Okay. Here data input and output. These are collect database document commonly used things predefined process. This is process start and end. This also start and question decisions. This symbol is used for decision and control repeat. Yes, these are the mainly we use process, input and output, sub-processes, start and end. You have to write start here. You can either write in simple or capital letters. You can change these things. And you have to input two first number, second number, first number, second number, and multiply. Multiply is a process, okay? Not an input to output. Multiply, no. Product is equal to the here you can input, you can write input num1, input num2, product is equal to the num1 multiply num2. Then this is uh, display. Display also output, okay? Display product. This one. So you can resize it, and then you have to write end. Then you have to draw this arrow to which direction it has to go. This is the flow chart, okay? You can if you want to use control structures like if then else like that, you can include this symbol. And if you want to there are other um, symbols also you can use. Preparation, this symbol you can use this symbol for loop also. This is sub process. Sub process is uh, if it is a large program, you can subdivide it. This subdivided program you can write in this type of process, this type of symbol. Okay. Now C programming, that is the second one. This is first one. C programming. Second one is C programming. And activity 2.1, you can use either compiler, code block, co-editor, any editor in the computer. You can download them, and you can use C program in code blocks. ID. The code block is ID, integrated digital environment. These IDs can run without the internet also. But if you are using these online compilers, uh, you have to use, you need internet. I normally use online C compiler, this one. And the first one is write a basic program in C, welcome. Okay. Now, this is a welcome program. The first one is hash include stdio.h int main, starting the main block here, end main block here. you have to write printf, this one, return 0. Usually, when you open uh, uh, online compiler, it automatically gives this program. This also like a hello world simple program. You can identify this. Only thing different thing is welcome. Uh, this is return value. Okay, uh, you have to return output to the prompt using this one. In the after running this main program, you can uh, give prompt. Without this, you can write here data type. You can this by using this int, this program will return only integer values. Suppose if you want to write 0.4, hello world will come. Even this will print. Uh, there will be no error here, but it will return only the 0 value. Include steadio.h is, this is a function. Okay, this we call this printf is a function. This function is written in this. There is a file here. There is a subscript file called stdio.h. It comes with the compiler, C compiler. So there's a file called stdio.h. This stdio.h will attach to this program and run. Actually, it only attach this program when we write this one, and when we run it, it first attach and compile it. Compile is why do you need compile? This is actually user friendly. This hello world and printf, this we can understand this, but computer cannot understand these lines. So this code has to in computer, by using compiler convert these codes to a binary value, zeros and ones. So we can write in English, like in English here, the program. But earlier days, the scientists and programmers used binary code that is like zeros and ones. These writing programs in zeros and ones are very difficult. So what they do is they uh, they created programming languages, compilers and programming languages. So now it is very easy to um, create programs using not only the C language like Python or like that, C program, Python and Java, like those things. And this is the when we write program, you have to write here main function. Starting of this main function indicate this, end is indicates this, and printf. This is a print command. Print this will by using this command, it will print whatever we write here. In this lab we have written welcome to C. We can write here welcome to C. We can run it here. Welcome to C. You can write there is no visible things, but this is for welcome to C. We will print this one. If we write /n, the cursor will go down. Okay, one line go down, and this is about this one. This here you can see printf function /n mean go to new line. Copy the program to right. Okay, you can try it. Now you can write like this: welcome to C. Welcome first one. Then in the next line 2, the next line C, and print your name in the next line. Okay. Now welcome to C. You can write /n \n and print your name in the next line. How to do this? Uh, print. How to any name? Handling user input output performance arithmetic logic operations. Now here you have to input uh, 3 variables. Here you can see the flow chart here. Start, declare variables, uh, enter first number, enter second number, Sum is first number plus second number, print sum, end. Actually, these flow charts you can uh, write in different ways. This is like this. This same flow chart, different ways. You have to declare actually variables before that, before inputting. There are three variables here: uh, first number, second number, and the sum. So there are three variables. Uh, I get first number as A, second number as B, third, not the third number, sum as S. So we initialize these things and you can enter. First, I will um, uh, run the program without the initializing. Okay. This I will delete these things, and other thing is without I type these things also open, it will run. There's no problem. But we cannot understand later what is the where is the block uh, limits, block end and start of the block, and what the program we can easily understand later by using this indentation. Without indentation also this C programs will work. There are now other thing is if we have to declare variables with the data type. Here the data type is int A, int B, first number, uh, and the line. Now when you are inputting, there's other command called scanf. Scanf is if to get the variable values for the variable from you which should be user entered values. It will take uh, user entered values to this variable. So that the variable of the first number is A. We declared that is like this. Scanf um, you have to write like this: integer D. This is called placeholder and comma A. Printf, enter second number, scanf integer D. D indicates the D indicates this data type of this variable is an integer. This we normally use D for the integer, um, F for the floating point. and C for the cha means only one character. S is for string means more than one character. S is equal to the I think multiply, no? A multiply B. No, addition. Addition, okay. If you, addition is here, this. Printf, sum is integer t, comma, s. End line. You have to write and here, okay. When you inputting the values, you have to write this address of this, take as address, okay. You have to write and here. First number, say 12, 34. The sum is 34, 64. We can comment, check whether if we ignore this, two slashes mean comments. Comments is the compiler ignores everything, every lines. If we put these letters slash, if you write slash, these lines will be ignored. Here you can see without any inputting values, we put S is equal to the A plus B. So it will give some value. Why this? We didn't input anything, but actually if we didn't give any input uh, for the A and B, the sum should be 0. But it didn't happen. There is some value here. Uh, why this value here? Because for the A and B initially there is some value will be there, garbage value. We cannot say what is the value, and any value it will store. So that these values will be add and to the sum S. So we have to add, we have to initialize it, okay. A is equal to 0, B is equal to 0, C is equal to 0. Now what will happen? Now S is equal to, now the sum is 0. Now A is equal to 0. Now this is called initialization, because if we didn't initialize A, B and S, it will give a garbage value. So we have to initialize them, declare variables, initialized variables, and then go to the other functions. without without initializing separately, you can initialize here also, like this. Yes. Now remove the comments and run them. First number, sum will be like this. I think you can understand this. Uh, Initialization current one, num1, num2, we have to initialize. Then extend the program in activity 5. This one we already described. Extend the program in activity 5 to subtract, multiply and divide two variables with decimal points. Here you can see decimal points, okay, and the print results. But what we have to do to input, what will happen if we type like this? It will directly go to the second number and the sum. You can write here slash n also. Here 0.5 get as another number 34. If you want to uh, give decimal points, we have to change this data type to float. If you write you can see there are 1, 2, 3, 4, 5, 6 where 6 decimal places. You can limit these 6 decimal places to 2 using this point 2. Here you can see it will display only 2 decimal places. Uh, Now we can write subtracts a minus. We have to declare this variable here, float sub, go to 0, printf subtract it sub. You have to if the dividend below second number, if the second usually by 0, there will be 0 error. 0. You can write actually that is here if this semicolon is not included, there will be error. It will indicated by compiler, that is called syntax errors. But if we enter now here, you can see division is A divided by B. Okay, now run it. A div is not a div, is a what is called a keyword. Div is a keyword in C programming. So it will indicate by red. These all red are functions or keywords. Okay. Now we can write div1. Div1 also you have to declare variable div1 also. Yes, div1. Now the third value, no, second number, I put 0. 12.5. Second value is 0. Division is infinite, right? In some compiler, it is not given divide by zero error, but here it indicates that in that is infinite. That is you can't divide actually. Right? So you have to here you have to write control structure like if else. Here write a program to find smallest value of three numbers using if control statement. That is in this case we have to use if else uh, if condition. Okay, here there's no else. Input three numbers, initialize them. We declare that smallest is 0, first number, second number, third number. Smallest is A. At the beginning, we put smallest as A. If smallest greater than B, then smallest is B. If smallest greater than C, smallest is C. So after that, print smallest as smallest. Okay, I will write this program here. Without this thing is also it will run. Okay, integer A. I will put only the integer values. Okay, yeah, we can write like this also. No, A is equal to we can't initialize int. P is 0, int C is 0. Uh, Initialization and declaration, or both steps are in a single step. Printf, enter first number, scanf, integer D, comma, you have to write comma, okay? A. Now, and A. Printf, enter second number, scanf, integer D, and B here. Printf, enter third number, scanf, integer percentage, okay, not integer, percentage D, C and C, uh, and then what should do? If no, First we have to declare of 2 to the smallest, to the variable. We have to write day ahead. Smallest a, if smallest greater than b. Now if you write if, like control structures, if for loop, uh, we don't write at the end, we don't write semicolon here. Start the block, and if the smallest greater than b, smallest equal b. Here value of b will be assigned to the smallest. If smallest greater than c, smallest equal c. That means the value of the c will be assigned to smallest. Close the, open the block, close the block. Then printf smallest, smallest equal contains t. Here you can write the variable name small. What is the problem here? 34. Right. Where there was a extra close bracket. First number 12.4. No. we have to input only the integer values. Okay, 12, 45, 3. Smallest is 3. It will print smallest is 3. Now here you can see now in this flow chart how is the flow chart we can write, we can draw. If the smallest grade, it checks whether smallest greater than b, yes, smallest is b. If if not correct, the program goes to here this below steps. It then again it checks whether smallest greater than c. If it is yes, smallest, the value of c uh, assigned to the smallest variable. So print the smallest. Then write C program to input character A, B, C and display if the input is A, then print 1. If the input character is A, then print 1. If input character is B, then print 2. If input character is C, then print 3. Else print wrong character. When the when run the program, first print enter the character ABC and input the character and input the you have it will the program will print enter print plus print enter character a b within brackets a b a comma b comma c and then input the character. um, how to do this program? This is related to the characters. Okay. Oh, write a C program to characters A declare and initialize. We have to declare variable cha, data type is cha. Cha any name uh, 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 cha b1 printf enter character in brackets A comma B comma C. End of the line and then uh, scanf percentage C comma uh, V1. Here we don't write and sign before this variable because of this cha. If V1 is it checks, okay. uh, A. We can write O O O O also O here also. If V1 equal, okay, equal, but equal is this one. A V1 not in if input character is A, then print what? If we A 1, then V1 printf mm, 2 semicolon, else if V1 check whether equal, you should write to check whether equal, you have to write two equal signs. C uh, 3 else printf printf print wrong character. Okay. Semicolon. Okay. Yes. Now, what's happened here? So, and if and you have to write and for the V1 for integer, float, and also characters. But if you enter set of characters, that is called strings. When you input several characters, you have to declare it as a char array, and then no need this and sign. But here, if it is only one character, you have to write C, and if set of characters, you have to write S here. And this actually this open brackets and close brackets, if we okay, start recording. Now even these brackets are available. So if it has a one line, and now before that we will run this enter character A, print, it will print 1. B, it will print 2. If it is C, it will print 3. If you input D, it will print wrong character. Now, according to this question, it is okay now. Now here there are two brackets here, but if we have written only one line here, no need these brackets. If we write more than one line, you need brackets here. Now, because of this only one line here, we can run this without these brackets also, like this. Also, right. Yeah, the program will run. But if you want to add another line here within this if blocks, you have to enter this open bracket and close bracket. Question activity 2.9 question: odd number or even number? Write a program that will obtain an integer number from the user and determine whether it is an odd number or even number. Hint: all even numbers are divisible by 2. And here we can declare integer number n1 initialized, enter, enter, uh, enter number, and percentage d comma and n1 semicolon, control structure if uh, percentage 2 n1 percentage 2. What is this n1 percentage 2? That is uh, it divided by 2 and check the remaining. Okay, now if we if we um, if we enter the number 4, okay, 4 divided by 2 is 2 and remaining is 0. If we input the number 3, 2 3 divided by 2 is uh, uh, 1.5. The remaining value is 5. So it is now it check whether that is equal to the 0. If it is 0, then um, then it is an even number. Even number is 2, 4 like that. Odd numbers are 3, 5 like that. Printf even number. We can write like this. Percentage D is an even number. N1. Now here at the earlier programs I put percentage D here. So now I put percentage D here. What will happen? This variable value of the variable will be written here and then is an even number. Right? Else check percentage. Well, 12 is and now you can see 12 variable value will be written here. 13. 13 is an odd number. Yes. Now, now here the lower character, simple letter, and display the lower character and display the respective upper letter. You have to enter lower character and then display the respective upper letter, uppercase letter. Write a program that will ask the user to enter a lower character, simple letter, and display the respective uppercase letter. If the user enters invalid character, display an error. You may use ASCII table to find simple approaches to solve this problem. Now input a character ch. Variable name is ch. Print Now input the character value, and then if ch greater than or equal a and is now in C programming we can write logic and O and tool both should be both now the and ch less than or equal to the z. Here the variable value of the variable ch greater than or equal to the simple a and below ch less than or equal to the z. Okay, it takes the actually uh, ASCII values. So it will take this ASCII value and then it checks whether these conditions are um, correct. Okay, and sign is both conditions should be corrected. Uh, both should be true. Okay, so we can write O sign like this using this. Here we use and sign here and ta upper. You can write another variable upper. A minus z. The uppercase letter is percentage C. Now there are two lines here, so we have to include blocks here. Else now minus. Okay, simple A, capital A. Actually, we can write either this this or 32, because if you check in the internet ASCII table, ASCII character for the capital is 65. Now, here simple A is 97. What is the 97? 97 minus 65. 97 minus 65 is 32. Okay. So this also this A minus Z, that also 32. 32. You can write either like this or this. 32. No, that is wrong, I think. No? Not Z, capital A. Okay. Yeah. Now it's okay. However, this this value is A minus capital A is 32. So CH minus 32. Value of the simple letter minus, here you can see simple A, capital A, simple B 98, 66. All are same difference. Other thing is calculate the interest. Write a program that will calculate the interest given the account type and the account balance. Here write a program that will calculate the interest. Okay. We have to input the value, the value we deposit, and the type. Here there are two types, type R, type S. If it is a type R below 10,000, the value, the interest value is plus 2%. In this range 2.5, in this range 3 percentage, here 5%. If the type is S, these are the interest rates, percentage side. So we have to write a program, C program, to address this problem. Now we can declare value. float. Okay, we can write double float has limited. We can input limited length -2 plus limited length. If you want to above these values, we can write double like. But remember, if we input declared this value variable data type of this variable as float, it take memory space less than the double. Or to allocate the value 8 point 2 is 20%. If it is 2%, that 2% is 0.02. Else, if type equal s interest equal value multiplied by 0.04. Else, printf wrong type. Now here if else. Now we can copy this also. Else if value less than 50,000. Now first it will check whether below 10,000. Then not, that means if it is not greater than 10,000, if it is greater than 10 between below, now between this and 50,000, 50,000, uh, we can copy here, change the interest type, point not 25, point not 25 to point not 5. Else if value less than 100,000, less than 100,000, type var, uh, point not 3, point not 6, not 3, point not 6. Else, okay. Else, point not 5, point not 8. Then after that print interest is percentage point 2 f interest. There may be errors. I will check. Printf wrong type. Semicolon you have to put in everywhere. enter type. Interest is this one. Now this is the program for question 2.11. This actually we discussed here sequence selection, not iterations. Iterations is like for loop. We didn't discuss in for loop will be discussed in second lab. The first lab we discussed here if else and the input output and processes how to do by C program. Now, if you have any problem, please ask. Okay. There is an I just rename mine. Okay, okay.